I created a system of independently acting neurons that seek connection with each others based on their utility. And I tweaked it to predict price movement, specifically the direction of Nvidia stock. A little description. Synapse receives information by connection to axon. Then the dendrite reunites signals from its synapses active this period. Each dendrite has many synapses. After that, the neuron subs up signals from its dendrites and passes it through filter. Then information flies into axon, and new time period begins. As you see, the main computations are in the synapses. In this version of the model, I have some differential approach. The excitation of energy in the synapse depends on the previous calculations, and I did this through a simple discrete coefficient. If the previous result was higher than a given threshold, then the coefficient increases. Besides that, outflow from axons undergoes changes in the external environment before getting into the synapse. In my case, it's just an external coefficient. I used a system of nodes as a coordinate grid to calculate the attractions and the movement for the dendrites. Each dendrite moves to the most attractive node. The attractiveness is inversely proportional to the square of the distance and proportional to the energy of the node. Energy is simply the number of active synapses contacted. Each period, each dendrite identifies an attractive node and begins to grow in its direction. If during growth a dendrite passes through a new node, it creates more synapses and these nodes. Already inside the node, synapses randomly connect with the axons. The connection is established if there is no drop in utility in the overall system. This is where the system is trained as a whole entity. Also, I provided a mechanism for disrupting the connection. Under certain circumstances, the synapse breaks the connection, and if the utility has no fall in this period, the break remains valid. Network architecture. We have 8 special sensory neurons that see only positive returns and 8 only for negative returns. And so the system only looks back 8 periods. Then there are some predefined frozen contacts. Can't be changed. They are not really needed, but I thought they provide some stabilization. There are also 2 output neurons. One for going down, one for going up. And there are about 16 neurons in total. Each has 15 dendrites. Each dendrite has synapses equal 5 times the number of the nodes where the dendrite is situated. Information flows sequentially. That is, each period the synapse receives a signal from the axon. A transformation occurs, and what has been obtained goes to the axon of this neuron. But from them, signal goes to the next period. The utility function is very simple. If the system correctly determines the movement of the next period, it gets +1 to the utility function. If it's wrong, then -3. Failures weigh more than victories, like in our brains. Now the most interesting part, results. I didn't train on all the available data for Nvidia stocks. I trained on just one run of 20 periods, and I checked the result on the next 20 periods. And I did this about 20 times. Here are the ranked results. The main conclusion is this. If the accuracy during the training period is higher than 0.5 and lower than 0.66, then you can safely use the results of the intelligence hint. If the accuracy is higher than 66%, overtraining is observed. In fact, if the accuracy is below 50%, you can use this network's prediction, but with the opposite sign. Not bad, I think. Technical problem now is saving and loading internal connections.